Hey there, all you lovely Longhorns. It's Miss Campbell here, and today we are going to talk about points, lines, and planes and rays and naming them. Okay, so a point is an exact location in space and it has no width, length, or depth. Okay, so the way you show a point is by making a dot and you label it with a capital letter. So this could be point P. Okay, and sometimes you'll hear it referred to as point P, or sometimes they will just say P. And you're to understand that when they're only saying one letter, then they're referring to a point. Okay, so these are the names. So you name a point, you say point P, or you just use the capital letter. Next thing we have is a line. Okay, it is a straight line of points and it extends infinitely in both directions. It has no thickness and it's named by 2 points on the line. And there is exactly one line through any 2 points. So that means you can't draw a bunch of different lines going through the same 2 points. Whatever line you draw through those 2 points, that's the only line that can be drawn through them. Okay, and here it says it's a straight line of points extending infinitely in both directions. So in reality, you have point after point after point after point after point after point, and they're literally all so close together that they are making a line. So that's kind of where that comes from. But this is how a line is going to look. You have a point here, and you have another point here, and you have your line, and it's got to have arrows on the end because it goes off infinitely in both directions. So this line here, okay, call this point A, call this point B. All right, we can call this line A, B, okay? Or we can use the symbol for a line. So you write down the 2 points, A, B, and then you put this line above it with 2 arrows on the ends. And so that is how you will call it like geometrically. That's the formal name for it, is the 2 letters of the points with that symbol for a line above it. Now, a line doesn't only ever have 2 points on it sometimes, sometimes you'll get a line that only has 2 points marked, but, there could be a third point over here, all right? This could be point K, all right? Point K. So another way we could name this line would be line BK, or we could call it line KA, all right? So for when you're naming lines, the order of the points does not matter as long as you choose 2 points on that line. So that's why KA can work even though it's going from right to left. All right. And then an equivalent name for that would be AK. Okay. And all the names for this line that I've come up with, they talk about the same line. So KA is not any different from AK. It's the same line, it's just named differently. It's kind of like, you have your name and you might have a nickname. You're the same person, but people call you by different things. That's what's going on here. And for a line, you only ever need 2 points. You don't use 3 letters on the line. You just use 2 of the letters that are on it. Okay, now a line segment. That's just part of a line and it ends. So a line segment has ends. A line goes on forever. So a line segment can look like this. Okay, H, I. And you can refer to it as segment H, I. Okay, but the proper way to do it is to put the 2 letters and then you put a straight line above it. No arrows or anything like that. You can also call this segment IH. It's the same segment. Okay. Collinear. That just means points that are on the same line. So here's our line. Okay. You can have points D, E, and F. Okay. Points D, E, and F are collinear. Okay, collinear, because co means together and linear means line, together on the same line. All right, so let's do an example here. It says, what are two other ways to name, let's look at our symbol, line QT. Okay, line QT, let's locate it first. All right, it's right here. This is line QT because it's going through the points Q and T, and you have to draw that line. All right, another way that you could name it could be QN, okay, line QN, because you see N is also on that line. We could also call it line NT. Or if you look, you see this little letter right there? We can call it line M. Okay, sometimes lines will be labeled with a single lowercase letter. So lines get labeled with lowercase letters. Next thing, name 3 collinear points. Okay, we can actually name several sets of collinear points. Let's look at that line that we just worked with. N, Q, and T. Those are collinear. N, Q, and T. And then there's also another line in this picture. So we have those 3 points there, R, Q, and S. Those are also collinear. So as long as they're on the same line, they are collinear. Okay, it says now name all the different segments in this picture. So remember, a segment is just a piece of a line. Okay, now when you're naming these segments, sometimes they can overlap. But let's look at the obvious ones first. We have DE. Okay, and make sure you put the segment symbol there, DE. And then EF. So you have those 2 little pieces, right? What about the whole segment from end to end? DF, right? DF. And then, I don't know, are there any other ones? FE, it's not a different segment from EF, it's just named differently, okay? So let's make that note. EF and FE are the same segment. So there's not really any other segments that are different that we haven't named. Okay, now it says, are segment DF and FD the same? You can tell if a segment is the same if it goes between the same 2 points. It doesn't matter the direction for segments. So do segment DF and FD go through the same points? Yes. So yes, because they go through the same points. Okay, so there we go. And they have the same endpoints. Because the segment ends at D and F both times. All right, next vocabulary that we have is array. It is a line that has one endpoint and extends infinitely in one direction. So basically, array, it starts right here and it's going to go off in one direction forever. Okay, now to define array, you do need 2 points on it. So we can call this A and B. So this ray would be named as, call it ray AB. But really, you should write the 2 letters and then you put the symbol for array, and it's one arrow that's always pointing to the right. It's only got one arrow. So an arrow pointing to the right is ray. Pointing to the right makes a ray. There you go. However, be careful. You can have a ray, like an actual ray, that goes to the left, but you're still going to use that same symbol. So you could do this one here. It'd start at point C, and it's going to go off this way, maybe to point E. Okay? And this ray would be named ray CE. When you're naming a ray, you always start with the endpoint where it is beginning. Okay? So you start with the endpoint of where it is beginning. So that's why this one is ray CE. And people do get confused. Ray CE is not the same thing as ray EC. When you're naming rays, you do have to take into account the direction. Okay? So you cannot just name a ray in whatever order. It has to start with the endpoint. Opposite rays. There are two rays that have the same endpoint but go in opposite directions. Okay, so let's start here. We'll just draw a ray. Okay. HI. So ray HI. Now it says two rays that have the same endpoint but go in opposite directions. So for this ray, what is my endpoint? H. So my opposite ray has to start at H, but it's going to go the other way. So J. So HI, ray HI, and ray HJ are opposite rays. Okay, so ray HI and HJ are opposite rays. Key thing is that they start at the same endpoint for opposite rays. So let's do some examples. We have this picture here and it says to name several rays. Okay, let's start with the first one. Okay, we'll start here in the middle, E. If I go E, I can go to the right and get ray EF. Or I could go to the left and get ray ED. Also, I could start over here at point D. And I could have ray DE. Okay. Now, ray DF is the same ray because it's starting at D and it's going in that same direction there. Okay, so DE, ray DE, and ray DF, those would be the same ray. They're not different. Another ray, I could go the other way. I could start at F and go towards E. So I could have ray F, I could call that ray FE, or I could call that ray FD. Doesn't matter, because it's the same one. So I'm going to go with ray FD. Okay, so those are some of the rays in that figure. Now it says name a pair of opposite rays. Okay, when you're naming opposite rays, you have to choose a point that's basically in the middle. You can't choose point D because, yeah, you could have ray DF, but what about going the other way? You have point D, but you don't have another point to the left. So you can't use point D or point F as an endpoint for these opposite rays in this picture because they don't have any points outside of them. So you have to start at point E. So we have ray EF going to the right and ray ED going to the left. So that's our pair of opposite rays from that picture. Okay, next example. It says, are ray ED and DE the same? Well, look at it. ED goes this way and DE goes the other way. So are they the same ray? No. No. They go opposite directions. And also, key thing is look at their names. This first ray has an endpoint of E, and the second ray has an endpoint of D. So two rays cannot be the same unless they have the same endpoint. So they go in opposite directions and they have different endpoints. So when you're thinking about rays, I know I keep saying endpoint, and that's kind of like counterintuitive. The endpoint of a ray is like where it begins, if you can think of it like that. Okay? I know it's called the endpoint, but the endpoint is where it begins. Begins at the end. Okay, last couple ones here. A plane. A plane is a flat 2D surface that goes on infinitely in two directions, and it is created by three non-collinear points. Okay, it's a flat 2D surface that goes on infinitely in two directions. Guys, imagine a huge sheet of paper that just goes on and on and on forever in both directions, okay? Like it has infinite length and infinite width. So that is what a plane is like. So a plane is like a sheet of paper or like the floor of our classroom, okay? Or like maybe a sheet of metal, or like the road can be a plane, especially if it's a flat road, okay, like, or a field, right? A field could be a representation of a plane. So it's just a big flat surface, or like the top of a box, things like that. Now, to name a plane, it says it's created by three non-collinear points. So y'all, all it is, here's my plane. I have to have 3 points on it that are not in a line. Okay? You just can't be able to draw one line through those 3 points in order to name a plane. So point A, B, and C, this would be called plane A, B, C. Okay? Um, if you have, so if you had a thing like this where you have A, B, and C, and they're all in one line together, you cannot name a plane like that. It has to be 3 non-collinear points, okay? Remember, non-collinear means not in a line. So it's like they have to be spaced out on the plane. They can't all be together. Coplanar means points that are on the same plane. So we have a plane. Okay, and another way you'll see planes named is there'll be like a nice big script letter here in the corner. This is plane T. All right, that's a script T. All right. Now coplanar points. They're just points on the plane. They could be points in a line, okay? Because you can have a line that's laying on the plane. Like think about the road, the stripes on the road, those are lines. Or you could just have points randomly scattered here. So we can have E, G, H. So points E, G, and H are coplanar. Okay? And think about it. Points that are coplanar, can they also be collinear? Could all three of those points be on this line? Like if we move point E, could it still be on this line and still be on that same plane? Yeah. But in order to name a plane, those 3 points cannot all be on the same line. So right here, since we have these 3 points and they're all spread out, we could actually call this plane EGH. Or you can like HEG. You know, it doesn't matter the order of the letters, just as long as you have the 3 letters that are not all together on one line. So examples. And I think that's going to be the end of it after this. Okay, good. So what are 2 other ways to name plane P? So plane P, it's right here in the corner. And you see there's no dot next to it. So that's telling us it's naming the plane. Like you see how a V has this dot next to it? That's naming point V. Whereas this P over here has no dot, so it's plane P. Okay, now to name the plane, we need 3 points that are on that plane that are not all in one line. So I have that line, RS, that's running through the plane. I can choose 2 points from that and also point V, because point V is not on that line. So I could call it plane RQV, or I could call it plane VSR, okay? Plane QVS. As long as you choose 2 of these on this line plus point V, you can name that plane. Now it also says to name 3 coplanar points. Okay, just choose 3 points on that plane. V, Q, and R. Alternatively, R, Q, and S. Yeah, they're on the same line, but they're also in that same plane. So 3 points that are on that plane. And now it says, what is the intersection of line L and line M? Okay, we'll just look. Where is this line? Here's line M, right? And here's line L. Guys, where do they meet? Only at that one point, right? Point Q. We're going to get more into those intersections tomorrow. But just so you can see, 2 lines, they're going to intersect and they're going to make a point. All right, guys, so that's it for the definitions of points, lines, planes, rays, all those good things. Those are the building blocks of geometry. I hope you understand, and I'll see you guys later.